Hello everybody, welcome to Dr.K.Liu Math channel. This channel we will continue our the calculation of arc length. This time we will calculate the arc length for a parametric equation form. Before start doing this example, we carefully study this equation, the format of the arc length equation. First, for a curve, for example, I randomly draw a curve, which is from the domain to A to B, and then we divided this path, this curve, into a small piece, and draw a triangle. This is delta x, this is delta y, and then the delta s is equal to delta x squared plus delta y squared by the Pythagorean theorem. And finally, we sum up all the piece of small arc length, then we can get our final arc length of a curve from the interval from A to B. Okay, therefore arc length is actually equal to summation I from 1 to n square root delta xi square plus delta yi square, and take limit n tends to infinity. In the operation of this form, we can factorize delta x outside. Then this form can be rewritten as delta y over delta x. If we use this form, the integration is from A to B, square root 1 plus dy over dx all squared dx. On the other hand, if we not factorize the delta x outside, I use another color to do this question. If I factorize the delta y outside, then this becomes delta x over delta y I all square plus 1. If we use this form, we actually integration of dx over dy square plus 1 square root dy, and then the domain is from we may suppose this is C, this is D. The domain is from C to D. This is the difference between we treat this integration in different form. On the other hand, if the function of x and y are also is another function of something, for example, x is a function of time, y also something of time, then we can change this form. I use another color, also green color. The arc length can be written as this form. This form I move this into the original format. AB square root delta x square plus delta y square. Okay, if we suppose when t equal to alpha, x is equal to a, t equal to beta, x equal to b, then we change this format to delta x over delta t all square plus delta y over delta t square, square root, and then for the balance, outside balance a delta x, then this format can be a parametric form. This is from alpha to beta. This is our 3 different form of arc length actually they come from exactly one form. Okay, this is first part of the this video, and then for the second part we give an example to calculate the length of an astra of this parametric form. To study the form, we can plot some point to understand the shape of this curve. Otherwise, we cannot do anything. Once we do, we can start, we can plot something. Here I plot t equal to 0. Then xy, cosine y equal to 2, sine 0, cosine 0 equal to 1, then this 2, and then sine 0 equal to 0. For t equal to power 2, then xy is equal to 0, 2, and t equal to pi. Of course, has the 0 power 2 pi, 3 power 2, and 2 pi are three characteristic point of the sine and cosine function. Therefore, I want to put that is the reason why I put this value to test the graph of this parametric form. Okay, I speed up this one, and when t equal to pi, this is minus 2, 0, and this is 0, minus 2, and finally when 2 pi it turn and it go back to original point, these 2 points are same, this 2 point. Therefore, we can conclude that the format t equal, this is xy coordinates. The first point is 0, 2. Then the second point is 0, 2, and then minus 2, and then this minus 2. I randomly connect these points. This is astra. Actually, the shape of the function is like that. Okay, I better draw the exact. Exact shape of the graph. And now we can start to integrate the function, the r length. Originally, it is from I only need to integrate this part and multiply by 4 is all the length of this curve, and this is 0 to 2 if we use this format, 1 plus delta y over delta x squared, delta x. And then we can change to the domain when the point 0, this is correspond to x0 equal to 0, this point correspond to power 2. Therefore, this is correspond to power 2. When equal to 2, the point is corresponding to to 0. And then this should be dx over dt squared plus dy over dt squared dt. For dx over dt equal to dx over dt equal to 6 cosine square minus sine t all square, and dy over dt equal to 6 sine square t cosine t all square root dt. And then after make some simplification, this is actually very simple. Oh, sorry, I forgot to multiply by 4. This is 6 cosine x sine cosine t sine t dt. And finally, this is 12 pi over 2 to 0 sine 2t using double angle formula and integrate. This can be equal to 6 cosine 2t pi over 2 minus pi over 2 to 0, and this is equal to 12. This is the arc length for this astro. Yes. Hope guys can understand this the importance of the in calculating the arc length of a curve. Next slide I will to go to other topic which is shell method. And if you have other example, some example in related to arc length, in the calculating of arc length, you can send to me. Then I can present to you and share the how to calculate the arc length for something. Okay, hope guys can enjoy this video, and please subscribe my channel. Bye bye.